Let's talk about how we can verify the given solution, or like the solution you found by yourself, like from like fundamental set of solution. Okay, it's really easy as we discussed about it in chapter 3, and we will use the Wronskian. Okay, as long as your Wronskian is not equal to 0, then it forms like the given two solutions form a fundamental set of solution, right? It's the same thing in matrix solution as well. Okay, so in this problem, x1 and x2 is given. Then we're gonna try to calculate the Wronskian, where in matrix is exactly the same with determinant, right? And we're gonna check that it's not equal to 0. Then we can say x1 and x2 form a fundamental set of solution. Okay, so before then, let me verify like given x1 and x2s are solution of the given differential equation. I mean system of linear equation. Okay, so let's do it. So let me form one combined matrix X. Okay, there we go. Okay, I'm gonna multiply like e to the 3t like to the elements. Right. Okay, the next two is e to the minus t and minus 2 e to the minus t. Okay, then with these two vectors, I can set up the matrix, solution matrix like this way. E to the 3t, 2 e to the 3t, and e to the minus t, and minus 2 e to the minus t. Okay, then we need x prime, and x prime is like element-wise, right? Just take the derivative for each element separately, okay? 3 and minus e and 6, 2, okay? And plugging back into my system of differential equation. Then let me double check. Then, like, definitely the right hand side must be exactly the same, right? There we go. 1, 1, 4, 1, and my x is e to the 3t minus t, 2, 3t, and minus 2. It's okay. Let me calculate your right hand side, just like, the matrix product, right? It is. Definitely we're going to do row and column, right? Then e to the 3t plus 2 e to 3t, and it's the minus t minus 2 it's the minus, so this is minus t, okay? And 4 e 3t plus 2 3t, and 4 e to the minus t and minus 2, that's right? And you click at this guy, that is equal to 3 e to the 3t and minus e to the minus t, and 6 3t and 2 e to the minus t. When you compare left and right hand side, that's exactly correct, which means given x1 and x2s are the solution of the system of linear differential equation, right? So now we're going to verify it is really from our fundamental set of solutions, okay? As I told you, we're going to check the Wronskian of this guy, okay? Here we go. The Wronskian. As we discussed about this one in a previous theorem, that's exactly the determinant of this combined matrix, okay? So which is determinant of e to the 3t e to the minus t, 2, 3t, minus 2, right? AD minus BC, right? It is minus 2. It's the 3t minus t, which is 2t, and minus 2 e to the 2t, which is equal to negative 4 e to the 2t, okay? And don't forget this one, exponential function never be equal 0, okay? So which means this never be equal 0. Then finally, I can say x1, and since the Wronskian is not equal to 0, we can say x1 and x2 form a fundamental set of solutions, okay? That's it, okay?